So this is a second example for a grid method for the square root of polynomials. In this case, m and n here is not given, and we are told that this is a perfect square. So we know this is x power 4. So just like we did last time, we have our grid. Yeah, we know there is an x square term. Okay, fine, I'll use. But you know, all colors won't be the x term. And then you have, of course, a constant term, right? So that's a constant term. So x square term, x term, constant term. Yeah. So what we are told is this is 100. Okay, fine. I could have definitely colored that. That's one that is clear, right? Yeah, the colors are not clear because they are all mixed. But this is clear. This is 100. So we know this is a 10. Square root of that. So this one is obvious. Now this one basically corresponds to the x, which is 20 times whatever is the term for x. So I'm going to call it. Okay, this time this is m. No, this is not it. This is a and this is b, and square of that is that. Yeah. So basically 20 times b. 20 times b is this 220, right? So 20b is 220. This is clear. So b is 11, right? So I don't really have to fill this up, but this is clear. So now we get to the x squared term. So this let me just fill it up anyway. So this is 110x. So now we have basically 11. So this one, basically this one corresponds to the a times 11, right? So 2 times a, remember, this one is 2 times a times 11, 2a times 11, and I should not use multiplication sign, but it's okay. 2a times 11, which is going to become equal to nx, that also I don't know. Okay, fine. So I have to basically figure out a based on 361. Alright, so let's do that. The x squared term, this is 121x, this square, this we know, 11 times 11. And this term is going to be 2 times a times 10, right? 2 times a times 10 is 28. Okay, so I have 20a, which is equal to, I have to remove from this 361x square, 121x square. This is 0, this is a 4, this is a 240. So my 20a, yeah, I'll change color, is 240. So my a is 12. Ta-da! So of course the m is 12 square, that's 144. Right, and n is 2 times 12 times 11, right? So that is so 2 times 12 is 24. 24 times 11 is 240 plus 24, which is 264. Okay, so yeah, I mean we could also have done it as 120 plus 12, which is 132. So 132x cube, 132. I should not be using this color at all. Sorry. X cube and 132x cube. Total together gives you the n. This gives you x power 4. This gives you n. So if this looks haphazard, well, okay, let's just go over it again. This term is obviously being determined by this, so this is very straightforward. These two terms are a product of 11 times 10, which we didn't know it was 11, but basically 2 times 10 times whatever is this coefficient. So in this case it was 20 times that b. 20 times b was 220. Where is that? 20 times b was this one. So b gave me became 11. So then I substituted 11 here. Once I have 11 there, I know this is 121. x square. I know these two terms plus this term is what gives me x square. So I removed that. So now these two terms is basically this a that was there. So 20 times, because two boxes, 20 times a. So 20 times a gave me 240, which is what was remaining, this one. So that was what was remaining. So I got my a, I got my b. Once I got my a and b, then just a matter of getting m and n, which is straightforward. So this sort of grid method can be used to solve some of these questions as well.